Hello, Professor. I'm Haijie Yuan. Today is my final presentation, and my topic is brain-machine interface. I'm going to talk about BMI in 6 parts, and for each part, I divided it into different ways. The first part is background, and the first one is technology introduction. BMI is a technology that directly connects human brain activity with external devices so that the human brain can directly interact with computers or other external devices without passing through traditional neuromuscular channels such as keyboard or mouse. BMS divided into one-way and bidirectional brain computer interface. The second way is development history. The history of BMI dates back to 1924 when Hans discovered the human brain electrical activity using EEG. Vida created with coined the term BCI demonstrated the first non-invasive EEG control of computer graphics in 1977. Subsequent research continued, leading to advancements such as EEG control for robot in 1988 and bidirectional adaptive BCX in 1990. DARPA's funding since 2013 has further propelled BCI research. And the third one is research direction. The research direction of BMI includes connecting brain signal with external devices to enhance cognitive ability, designing intuitive interfaces, promoting neurologic rehabilitation, exploring brain network mechanisms, and realizing brain-machine collaborative learning. These directions are dedicated to exploring how brain signals can be used to connect with external devices to improve human cognition and perception, and to drive advances in the field of neurologic rehabilitation and therapy. The second part is concept development stage. The first way in this part is needs analysis. In user needs analysis, we first need to identify the needs and expectations of end user, including people with disabilities, clinicians, researchers, to understand their application, signals, and functional requirements for brain computer interface technology, so as to design solutions that meet actual needs. Secondly, we should carry out technical requirements analysis to evaluate the stability, accuracy, real-time, and the reliability of the system, as well as the advantages and limitations of the different systems, so as to make the designed products better meet the needs of user. And then it's a concept exploration. in the conceptual exploration stage of BCI. We seek new technologies to realize BCI by exploring different technical routes and methods, and try to explore the application scenarios of brain-computer interface in different fields such as medical, rehabilitation, game entertainment, and so on. Through user needs research and proof of concept, the preliminary prototype system is constantly designed and developed to verify the feasibility and effectiveness of the technology, lay the foundation for subsequent research and practice. And it's a concept definition. In the concept definition phase of BCI, we choose to make BCI systems for people with disabilities, which required us to take into account the specific needs and expectations of users, the feasibility and the reliability of the technology, and the needs and the competitive situation of the market. This requires us to analyze and define the key features, functional modules, system architecture, and other aspects of brain-computer interface technology in detail to ensure that the technology can meet the needs of practical applications. The third part is the BMS facing some challenges. The first one is a technical aspect. In terms of technical implementation, brain-computer interface faces three major challenges. The first one is signal quality and noise interface, because the brain signal is affected by many interference factors, and effective signal processing techniques are needed to improve signal quality. The second is signal decoding with high accuracy, which is a technical challenge to accurately interpret and understand complex brain signal patterns. The final one is real-time and low latency. Many application centers require brain-computer interface system to have faster real-time response capabilities, and reducing the delay of signal processing and transmission is one of the key technologies. The second is user usage aspect. For disabled users, firstly, the brain signals of disabled people may be affected by factors such as muscle and movement disorders, which leads to low stability and accuracy of the signals and increase the difficulty of signal recognition and decoding. More importantly, users need to train and adapt for a long time to master the system operation. So it is necessary to design interfaces that are easy to learn and use. Final one is stability of system. Brain signal accuracy may be affected by muscle activity, or environmental interfaces, resulting in unstable signal quality. Effective signal processing techniques are needed to reduce interfaces and improve signal quality. And the stability of the hardware device is crucial, especially for long-term use. Finally, the connection between actuators and the brain also needs to be stable for a long time to ensure reliable signal acquisition and transmission, which needs to solve problems such as electrode displacement and biocompatible. The fourth part is engineering development stage. And the first way is methodology. The focus of this section is to explain the various methods used in developing the BMI system. Here's an explanation of the methods. The first one is types of sensors. This part is to illustrate the types of sensors used to capture brain signals, including EEG, which measures electrical activity in the scalp, where the electrodes are placed directly on the surface of the brain, or functional magnetic resonance imaging, which measures blood flow changes to infer brain activity. We need to select appropriate sensors based on factors such as resolution and application requirements. The second one is signal processing techniques. This part is to illustrate the signal processing methods to extract the information from the raw brain signal collected by sensors, including filtering to remove noise, features, feature extraction, and normalization, which are carried out to send these different signals. In addition to this, advanced techniques such as time frequency analysis or machine learning algorithms can also be used to enhance the signal quality and extract useful features for further analysis. And the third one is algorithm to decode brain activity. This part is a algorithm developed to decode brain activity based on the processed signals. These algorithms convert neural signals into actionable commands that can control external devices or provide feedback to the users. Depending on the direction of application, decoding algorithms include classification algorithms for distinguish between different mental states, such as support vector machines, neural networks, and regression algorithms for predicting variables. The second way is hardware development. The hardware development section involves several key components which are designed and analyzed below for the sensitivity, reliability, and user comfort of the device. The first one is signal, ADC. In order to apply the brain signal captured by the sensor to readable life without adding significant noise. The amplifier must have very low noise characteristics and high input impedance to ensure signal integrity. The role of the analog to digital converters is to convert analog EEG signals into digital signals for processing. High-resolution ADC are essential for capturing brain signals, and the accuracy of the ADC affects the ability of the device to distinguish subtle changes in brain activity, which is particularly important for the device to understand the user's intention. The second one is a data processing unit. The role of the data processing unit is to process and decode the digital signal, and the dedicated DSP filter and enhance the digital signal, and then decode it into comments to interrupt the user's intention. BCI needs to process a huge amount of information. The device needs to use a powerful microprocessor for complex calculations. I use a tiny microcontroller for periphery control. The choice of architecture depends on the processor power and energy efficiency. Yeah. The third one is communication interface. The communication interface can transfer the dedicated commands from BCI to external devices or applications. There are two types of connections. First is wired, and second is a wireless module, like Bluetooth, Wi-Fi, and sometimes wireless protocols. The fourth is user interface and output devices. This is a key part of allowing the user to interact with BCI and receive feedback. Two sides of systems are divided here. The first is visual or auditory feedback systems. The second is the robotic arm in applications such as the brain computer interface must interface seamlessly with auto actor, which performs the action according to the user intention. The final one is component integration challenges. The components must be small and light enough for practical use, especially for wearable applications. This part is software development. Here is a comprehensive breakdown of the key stages and considerations of BCI software development. First one is the requirements gathering. Uh, determine what the software needs to do based on user requirements and technical possibilities. Some survey methods are used to collect the needs of the end users. First, the user needs to know the requirements of the device function, uh, and then they need to know um, the types of brain signal that can be interpreted should be included to design the function of the device. A second is system architecture design and algorithm development. A software architecture that is extensible uh, and meets defined requirements needs to be designed. And the designer determines the high-level structure of the system, including the choice of a monolithic design and the use of a framework or platform. And at the same time, it's decided how to integrate with hardware components such as signal devices and output devices. The third one is software implementation. Uh, the algorithm is transformed into an effective software system by design. We can use like C++ or Python, such like this. The development side includes writing the user interface, data processing, and integration logic. The fourth is test and validate in order to ensure that the software meets all specifications and user requirements without defects. Divided into unit testing, integration testing, system testing, and user testing, and other aspects. The fifth is integration and deployment. The seamless integration and deployment of software and hardware are realized. Our goal is to manage real-time data streams. The fifth part is post-development stage. First one is deployment. Conduct comprehensive testing to ensure that the BCI system, users, and environment are ready for implementation, allowing the system to meet all functional and requirements. We're preparing training materials and for users to help them understand how to operate a system effectively. The physical and software environments in which BCI are used to adjust to ensure security. And we talk about the installation. Install BCI systems in different environments, such as clinical settings, user's house, or other applications. Install all physical components of BSIR such as sensors and communication devices. install and configure software, ensure smooth integration of software with existing systems and hardware. The third one is integration with other systems. To support the needs of users, we need to coordinate the work of BCI with other technology systems, starting with data integration, establishing interfaces to allow BCIs to communicate with other medical or operating systems while sharing data. The fourth is monitoring and support. Provide a continuous monitoring and support to ensure that any issues are resolved smoothly. Establish support systems to help users with technical issues, including help desks and engineering teams. Then we want to talk about the maintenance. The BCI equipment is regularly checked and serviced to prevent failures and ensure that it maintains optimal performance. The predictive maintenance use data and analytics to predict and resolve potential failures. This requires us to continuously monitor system operation data for potentially problem and later use machine learning algorithms to predict when a component might experience performance degradation so that we can perform maintenance ahead of time. Software maintenance refers to keeping the software running smoothly and safely during the operation cycle of the BCI device. Regularly fix bugs that appear when the software is used in various practical sensors. Ensure the BCI devices meets all regulations and safety standards at the beginning of design and subsequent use. Then we talk about upgrades and scalability. Enhance the system, improve performance, and ensure that BCI devices can support a large number of users or new applications. Here is a detailed analysis of how to manage the upgrade of BCI. Like this. The first is a technology upgrade, and then the scalability, and we need to be compatible and the user-centered design. User feedback is regular calculated and analyzed to determine which upgrades are most needed and how existing systems can be improved to enhance the user experience. Ensure that system upgrades focus on improving user satisfaction and practical usability. The sixth is systems engineering challenge of the problem. First is signal quality and noise reduction. This paper analyzes the challenges of reliability and the performance of BCI from the perspective of signal quality and noise reduction. Like the following: signal and biological environmental interface, hardware-related noise. Second is the feature extraction and classification. The following is an analysis of the challenges encountered by PCI systems in translating raw neural signal into actionable comments or meaningful information from the perspective of feature extraction and classification, such as following. And the final is safety and reliability. Because BCI systems are usually done by implementing actuators or by putting non-invasive sensors on the scalp. Therefore, it's an important safety consideration to ensure the compatibilities of the implanted materials. The final part is summary and lessons learned. Summary is BCI is a pioneering work that aims to establish a direct communication path between the brain and external devices, enabling seamless interaction and control between the human brain and devices. Lessons learned through the BCI project. I understand the importance of cooperation, and a successful BCI project requires cooperation between different disciplines, including neuroscience, engineering, computer science, and clinical medicine, among others. That's all my presentation. Thanks for watching.